Well, hello. This is our Watch Edpuzzle Bohr model. This is what we're doing to fill out the notes on the left. There is a table on the upper right that starts with this. I want you to try to fill it in, and then once you've done that, come back. Okay. All right, let's check this. So all matter is made up of atoms. We know that. And atoms are themselves made of protons, neutrons, and electrons. So remember, atoms are the smallest unit of matter. Protons, neutrons, and electrons aren't matter, but they make up matter. For each one of these, we're going to go over the charge, location, and mass. This is going to be really important when we're constructing our Bohr model, which is just one model of how an electron looks. Okay. Protons, sometimes we do like P with a positive sign because they have a charge of +1. You can remember they're plus because protons are positive. Positive is plus. Their location is in the nucleus and they have a mass of 1. This is the unit that we use for mass is AMU, which is atomic mass unit. Okay. Neutrons have no charge because they're neutral. They have no sign. They're also in the nucleus and they have a mass of 1. And then electrons, its charge is -1. It is in the electron cloud, which is outside the nucleus, and it has no mass. So if you notice before when we were calculating the mass before, it was protons plus neutrons equal the entire mass. Well, that's because protons and neutrons are the only ones with mass. I wouldn't add the electrons because they have no mass. It doesn't matter. All right, so a scientist named Bohr created the Bohr model, right? Scientists are egotistical and they name things after themselves. All right, each energy level can hold a different number of electrons. All right, we can use the equation to determine, so it's 2n squared, to determine how many electrons each hold. So that means like if we're looking at the rings, each of these is an energy level. This is what we're going to be creating, a Bohr model. I think a lot of you have done this before. Every level is going to hold a different amount of electrons. N equals the energy level. Okay, so for your purposes for the intro, remember that the first energy level gets 2 and the rest get 8. Okay, just for now, intro, remember that. So we're going to go over the steps of how to create a Bohr model. Remember, this is like one version of what an atom looks like, just one version. There are so many out there. Okay, the first step is to determine the number of electrons. The second is to place the electrons on the rings, and each orbital or ring must be filled to move to the next. Okay, place the electrons on the rings. I'm going to also add from inside out. Okay, and I'm going to show you what this means. Let's do carbon. I'm going to do this side, and then you'll be able to do that side. All right, carbon. If I look at my fun periodic table, carbon has an atomic number of 6. Okay, so if it has an atomic number of 6, that means that my protons are going to be 6, my electrons are going to be 6. And in order to get my neutrons, remember I need to do mass minus protons to get that. Well, my mass, if I look, is here. My mass, if I round it, is 12. So 12 minus 6, my neutrons are also 6. Why is that important to know? Well, because when I make a Bohr model, my protons and neutrons go in the nucleus. So I'm going to say protons are 6 and neutrons are 6. If you can't see the symbols that I just used, I use these, the P plus and to the 0, and then I put the numbers 6 and 6. Now the fun part with this is placing the electrons. Alright, so this is when I use this table up here. I know that the first energy level, or the first ring, can only take 2 electrons. Okay, so I know I have a total of 6, so I can definitely put 2 electrons. I'm going to use a color so you can see. 1, 2, okay. And now I have 4 left. So my first ring is completely filled. I've put 2 on there. I can't put any more, but I still have 4 left. If you want to keep track, you can do 6 minus 2. I have 4 left. My second ring can hold a total of 8, so like, I'm good. Okay. So I need 4 left. I can put 1, 2, 3, 4. I always put the first 2 together like this, because that's always how they're filled. So I have a total of 1, 2, 3, 4, 5, 6 electrons. My first ring was filled, that's why I went on to the next one. My next ring is not filled, but I have no more electrons to put on there. So that is your Bohr model for carbon. A really quick check to know at least your outermost ring. Your outermost ring is called, that holds your valence electrons. Has valence electrons. Alright, so my outermost ring in this case had 1, 2, 3, 4 valence electrons. The way that I can check that, on my periodic table, I'm going to zoom out for a second. Okay, on my periodic table, remember I had you number the groups 1 to 18. That's the number of the groups, but I think a lot of you remembered, like a lot of you thought that this was 8. You weren't wrong for one case. So on the periodic table, on some versions, they have labeled columns 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. They skipped this whole transition metals section. That's because with here, I can predict the number of valence electrons. So for carbon, this says 4A. This means that any element in this row is going to have 4 valence electrons. If I look at my model, I can check myself. 1, 2, 3, 4. There are 4 valence electrons. I did it correctly. Your job is going to be to finish this. And then also, you are going to be doing all of these. So have fun and get started.